Lesson 7-1 is adding and subtracting polynomials and factoring out a GCF. Factoring out a GCF is like when you simplify fractions, you're reducing them basically. This lesson is assuming that you've taken 8th grade math, okay, and that this is a review, which means that there's a lot of content in here. So let's see if I can try to help you to understand this clearly. Here are some vocabulary terms. We have monomial, which is an expression that has one term. So an example of this would be like 2xy squared. That is a monomial. Even though it has 3 parts to it, it is not divided, or I'm sorry, it does not include adding or subtracting something from it. A binomial would be something like 2xy squared plus 3z. You have 2 terms separated by an addition symbol. And then, of course, bi meaning 2, like a bicycle has 2 wheels. Trinomial, tricycle has 3 wheels. That would be like 2xy squared plus 3z minus 7. Okay. And then a polynomial would be something greater than 3 terms. So each of these are a term. Okay. Now, when we are dealing with polynomials, you want to order them a certain way. And we order them by degree. So if you look here, a degree of a monomial, you sum up all the exponents of the variables in that monomial. So if I have a monomial that looks like this, I would add up all my exponents, and that number or that value is the degree of the monomial. So that's what that is. But when you have more than one term, so if you have a binomial or greater, you take the term that has the greatest degree, and that would be the degree of the entire polynomial. So for example, if you look right here, the degree for this is 3, right? The degree for this one is 1. So because this monomial, the first one, has a degree of 3, that would be the degree of the entire polynomial. Okay, and I'll show you what that looks like in just a second. Your leading coefficient is the very first number in the entire polynomial. So in this right here, my leading coefficient is 2 because it's in the lead. It's the first one. And then the standard form of a polynomial is ordering your terms in order from greatest degree to least degree. So let's practice some of this here. We have -7 x to the 4th y z to the 5th, and that y actually has an exponent of 1. And I want to determine the degree. So that means that I find the sum of the exponents. So I have an exponent of 4 plus an exponent of 1 plus an exponent of 5, giving me a total degree of 10. That makes sense? Yes. Okay, here, and when you're talking about a degree, you're only talking about exponents, not coefficients. So the degree of this monomial, here, adding up the exponents, you have 1 plus 3 plus 2, that gives you 6. Okay. This one has one variable to a degree of 1, so the degree is 1. And then 10, there are no exponents. There are no variables with exponents, so 0. Okay. Now that's when we're dealing with monomials. When you're dealing with something greater than a monomial, then there's a little bit of a difference there. So let's look at these examples right here. We're going to write each polynomial in standard form. That means that we're going to order them from least degree to greatest degree to least degree. So if you look at this term or this binomial right here, the degree of 3x is 1, and the degree of 4x squared is 2. So that means that 4x squared needs to come first. So 4x squared plus 3x. Okay? That looks like an 8 or something else, but that's a 2. My leading coefficient is the first number in the first term. If there was not a number in the first term, so for example, if I had x squared plus 3x, my leading coefficient is 1. Since I have a number in the first term, my leading coefficient would be 4. So make sure that you put your polynomial in standard form before you determine the leading coefficient, because if you don't, you would think that the leading coefficient here was 3. All right, the degree of the polynomial. So since we're dealing with a polynomial, when we're finding the degree, we only choose the term that has the highest degree. In this case, this term has the highest degree of 2, so our degree is 2. We don't add the 1 to it. So the degree is 2. And then the name of the polynomial, since it has 2 terms, is a binomial. Okay. I'm gonna skip down to the next example, and then I'm gonna have you do the 2 practice ones on your own. So let's go to this example. The first thing you want to do is you want to total up all of the degrees of the polynomial. Okay, so this has a degree of 0, 5x squared has a degree of 2, negative x has a degree of 1, and 7x cubed has a degree of 3. So now I'm going to write it in standard form based on the degrees. Make sure you take the sign in front of it when you rewrite it, okay? So this is 7x cubed plus 5x squared minus x plus 8. In the practice one, there's more than one variable. Make sure you total up all of the exponents for all of the variables. Now, my leading coefficient is the first number, so that's 7. The degree would be the degree of the leading term. And so the degree of the leading term is 3. And that's the degree of the leading term after you've written it into standard form. And then the name of the polynomial, there's 4 terms, so just polynomial. There's a name for one that has 4, I think, or quad, something like that. But we're just going to call it a polynomial. Okay, I would like for you to go ahead and do 2 practice ones on your own. I'm going to pause the video, and when we come back, the answers will be up there. Oops. Go ahead and check your answers for the 2 practice problems. Okay, any questions? Oops, I grabbed the wrong pen. All right. Moving on to page 2. We are going to add polynomials. All we're doing here is we're adding like terms. When you add like terms, you do not combine any form of the variable or the exponents by adding, subtracting, or multiplying. Remember, when you're adding polynomials, your variables with coefficients are like denominators. They stay the same. So I have 4x, I have this polynomial minus or added to this trinomial. And there's different ways that you can do this. But the first way I'm going to show you is just by circling the like terms and adding them together. So my first one, I have 4x squared minus 2x squared. And when you write your final answer, it must be in standard form. So 4x squared minus 2x squared is 2x squared. Okay. Now I have a negative 8 cubed, and I have a positive 3 cubed. So when I combine those, I get a negative 5x cubed. I don't think I said the x when I did that. Okay. Next, I have a 1, and I have a 7. 1 plus 7 is 8. And then in the next one, I don't have another color. We have just an x, and we have nothing to combine it with, so it's just plus x, okay? Now, I'm going to write my final answer on the line, but it has to be in order from greatest degree to least degree. So here's my greatest degree, negative 5x cubed. And then plus 2x squared plus x plus 8. Okay. So this is one way to solve it. Are there any questions on that one? Okay. So I'm going to show you another way to do this. I'm going to look at my first set of, my first polynomial, and I'm going to order it from greatest degree to least degree. Okay. So I have negative 2a to the 4th plus 3a squared minus 6a plus 5. And then I'm going to take my second polynomial and I'm going to stack it under, but when I stack it, I have to put like terms under their like terms. So for example, negative 8 is going to go below negative 5. A is going to go below negative 6. So that would be like a positive 1a. A squared is going to go under 3. And then negative 5a cubed will go under the negative 2. Oh, nope, that's not what's going to happen. Negative 5a cubed, that there is nothing to combine that with. So I'm going to put that at the bottom over here. And then I'm going to combine my like terms. And remember, when I write my final answer, I have to put it into standard form. So I end up with negative 2a to the 4th plus 4a squared minus 5a minus 3 minus 5a cubed. And I just have to make sure that that negative 5a cubed goes behind the monomial with the degree of 4. So are there any questions on what I did? If you don't like this way, you do not have to do it this way. So I'm going to write my final answer up here. So negative 5a, no. Yeah, negative 2. Negative 2a to the 4th minus 5a cubed plus 4a squared minus 5a minus 3. Okay. So what I want you to do is I want you to do this one, but I want you to do it in whichever method that you prefer. Okay. Ooh, that was close. Okay. All right, check your answer and check my answer. Any questions? Okay, let us move on. One moment. Okay, we're going to pause and come back in a minute. Now we're moving to subtracting, which is different. There's one step different. Whenever you have a negative in front of a parenthesis, it's like a -1, and you must distribute it to all terms inside of the parentheses. So for example, we're going to imagine that there's a -1 here, and we are going to distribute that -1 to all three terms on the inside. So we end up with 6x squared plus 4x plus 2. We're not doing anything with the first set. And then we distribute the -1, and we end up, and we're going to add it to -2x squared plus x minus 8. So we basically just set up an addition problem. And now we're going to combine like terms. Okay, so I have 6x squared and -2x squared, which gives me a 4x squared. I have a positive 4x and a positive 1x, which gives me a positive 5x. And I have a positive 2 and a -8, which gives me a -6. And that's already in standard form. Okay. All right. I think you guys can do these two on your own. You want me to do another one? I'll do another one. All right. If you don't need it, then just go ahead and work on your own. So I'm going to take and I'm going to distribute a 1 here to each term. Now I rewrite the whole thing. You don't necessarily have to. I have -5z plus 4z squared plus 3. And then I'm going to rewrite my other set of parentheses, but by distributing that -1, I actually turn it into adding like this. And I end up with -3 plus 2z squared plus, oops, not plus, hold on, minus, if I'm distributing a 2, minus 7z cubed. Okay. Now I'm going to combine my like terms. So I have 5z. Oh, I don't have anything to combine it with. And I have 4z squared and 2z squared. I have 3 and -3, which is a 0. Those cancel out, so I don't need to do anything with those. And then I have a -7z cubed. Okay. So now I'm going to write my final answer in standard form. Okay. So check your answer, and then I want you to try practice the next practice one on your own. I'm going to do this one a little bit differently if you want to. Go ahead and check your answer. Are there any questions on this? Okay. Okay, let's go ahead and go to the next page. Unless there's an objection. Okay. All right, let's go to the back. We are going to factor polynomials. Now we're going to end up factoring lots and lots of polynomials, but this is just one type of factoring, and that is factoring out a GCF. So what we're doing is we're looking at these two terms and we're saying, okay, what can we reduce the two coefficients by? And then what can we reduce the variables with exponents by? So let me walk through this one really. Let's see if I'm going to go through it a little bit slowly so we can see if you guys understand. So 9 and 12, they have a common factor of 3. So I know that I'm going to divide this by 3 and this by 3. Okay. Now, the first term has 4 A's. The second term has 2 A's. How many total A's can I reduce out of both of these terms? 2. It's like 4 over 2. 4 over 2 A's, you can reduce those both by 2. So I'm going to take 2 A's out of this one and 2 A's out of this one. I can't take more than 2 A's here because then I would have a negative, and that doesn't make any sense. How many total B's? 5. So I can take 5 B's out here and 5 B's out there. So what I have discovered here is that the GCF is 3a squared b to the 5th. Okay? That's what we just did. Now I'm going to divide each monomial. And when I do that, 9 divided by 3 is 3. A to the 4th divided by a to the 2nd. What do we do with our exponents here? We subtract them. So 4 minus 2 is 2. So I have a squared. And then b to the 7th divided by b to the 5th. Subtract my exponents and I get b to the 2nd. I'm going to do the same thing to the other one here. 12 divided by 3 is 4. A squared divided by a squared is 1. They cancel out. I do not need to write anything for those. And then b to the 5th over b to the 5th, they cancel out. Okay? So I'm going to write my factored expression, but then I'm going to write my final answer below it. Okay? So my factored out expression is 3a squared b squared plus 4. Okay? Okay. Here is my final answer. Okay? 3a squared b to the 5th. 3a squared b squared plus 4. This right here is my final answer. Okay. Well, if you were to solve this, let me show you what would happen. Right? You mean like distribute it? Yeah? Okay. Let's say we distributed this back together. We would end up with 9, a to the 4th, b to the 7th, plus 12, a squared, b to the 5th. That's what we started with. So what we're doing is we're doing the reverse of distributing, and we're factoring out. Okay? So that's kind of what we're doing here. So let's do this practice one here. I want you to come up with the GCF on your own. Try to do that, and then I'm going to work on it up here, but don't look up here until you have the GCF. Okay, when you have it, you want to make sure that's correct. Okay. Okay. Make sure you factored it correctly. Okay, any questions on that one? Okay, I want you guys to do, oh, I need to do this one with you. I'm sorry. Yes.
General, if try to find the GCF, like for example, instead of 9, you put your feet, would that be wrong?
Yes, because then you're not factoring it out fully. It would be like reducing a fraction, but not all the way. Yes, that was a good question. Okay, on this one, anytime your first number has a negative, you must factor out a negative. So for example, between -4 and -6, the common factor is a -2. Okay, so I'm going to factor out a -2 on both of these. Okay, I can factor out 2m's. I can factor out 4n's. Factor out 4p's. Okay, so my GCF is -2 m squared n to the 4th p to the 4th. Okay, right. So -4 divided by -2 is a +2. M to the 3rd minus n to the 2nd or divided by is m. Our n's cancel out. And p to the 6th divided by p to the 4th is p squared. Hold on. Okay. Oh, it's not letting me do that. Okay. Hold on. Okay, so I lost my train of thought. Okay, so now -6 divided by -2 is a +3. Our m's cancel out. Our p's are going to cancel out, but we're going to be left with n to the power of 2. So 2m p squared plus 3n squared. And so when you write your final answer, you have -2m squared n to the 4th p to the 4th, and in parentheses 2mp squared plus 3n squared. Okay. And looking at the last 3 on here, I am pretty sure you can do these on your own. So I'm going to pause the video. I'm going to let you work these out. And when we come back, we can check our answers and then we'll be done with this lesson. Okay, these are the last 3 problems on the notes. So go ahead and check your answer. And this concludes lesson 7-1, adding and subtracting polynomials and factoring polynomials using the GCF.